She
Yeah, but
knows
that's
me.
all right. Big up Carissa one time. I'm waiting to go live on YouTube. YouTube. Okay, cool. Working. Nice. All right. Ready to go. Oh, let's see math vibes in the background. Madness, madness.
Yes.
Yeah. All right. Yeah, I went Shiva Boys. That was my school. Yeah. Joshima, what school you going?
Really, so
Rio? Rio East?
yeah.
Oh, okay. I was just gonna see how the live looking on TikTok. All right, nice. We ready, we ready, guys. Let we go. Are you ready for action? Someone know.
Yes, sir.
Hey, look, I'm calculating my confidence. Just here for singing. I can, guys, and I can sing, and I can sing, guys, and I can sing.
Yes, sir.
Now I know. Yeah, I can real sing, boy. Such anyway, you were going to sing or for what?
Me?
Well
Nah, I
enough.
feel
Yeah.
you going.
You
You
feel
go.
I go in.
Yeah.
All right, so let me jump straight into it. So let me just give you guys a quick review of what rates are changes. Quick review. So most people don't do hard maths. Just saying that most people don't do hard maths, but you could learn some stuff. Let me give you an example, right? Let's just say you had a cup here, a cup. I am pouring water into the cup, right? So Jenna, if you have a cup and you're pouring water into this other cup, what's gonna happen as time passes? What's gonna happen?
Before the water will increase.
Right. So hope that makes sense. As we pour water into that cup, the volume is going to increase, right? That makes sense?
Yes, sir.
Okay. Josh, Sachin, Virginia, that makes sense, right? Like, as you pour water into the other cup, the volume is going to increase.
Yes, sir.
Yeah. Yes, sir.
Right. So as time passes by, Josh, as time passes by, what's changing? As time passes by, what's changing?
So no, the how did the score again? I forgot enough. I
Hmm.
honestly forget.
All
Yeah.
right, the volume. The volume. So the
Oh,
volume
so yes, sir.
changes with respect to time. All right. And Jenna, what else would change? Talk to me. What else would change? What's this?
The height.
Exactly. So the height would also change as well. All right. So guys, if any of you are confused, dVdt just means a change in volume with respect to time. And that makes sense because like as more time passes by, more of the water in this cup is going to be transferred to that other cup. And that other cup, the volume is going to increase. Hope that makes sense. And as more time passes by, the height the height in this cup is going to increase. That makes sense?
Yes, sir.
Cool. Now, this is one a lot of students might not see. As as the height changes, what also changes? Talk to me. As the height changes, what also changes there? As the height changes, what's changing?
Volume.
The volume, yeah. So as the height changes, the volume increases. So the volume is increasing with respect to the height. People on TikTok, I know a lot of people don't do hard maths, so this is probably the first time you ever seen hard maths in your life. So let me know if all you understand. So what I'm saying is, you have a cup, right? And this cup is originally empty. That cup originally empty, right? And you're pouring water into that cup. Now, as time passes by, the volume in this cup is going to increase. So the volume is changing with respect to the time, right? And that's called a rate of change because the volume is changing with respect to time. And then what else we notice is that the more time passes by, the height rises. So what's changing? The height is changing with respect to the time. Now, this one is a bit harder for students to see, but I'm gonna ask that question, right? Kamaya, if the height is increasing, what's increasing as well? Talk to me.
The volume.
Exactly, the volume of water. That makes sense, right? So as the height increases, the volume of water in that cup also gonna increase. So you with me with that? Right?
Yes, sir.
Okay, cool. And so this is a concept of rates of change. We're looking at the rates in which things change. So in this case, volume is changing with respect to time, height is changing with respect to time here, and volume is changing with respect to height. Now we could actually connect two rates of change to get another one. So let me ask that question, Kamaya. Let's just say we wanted to get dVdh, right? Kamaya, stay with me. So Kamaya, if I wanted to get dVdh, I would multiply two different rates of change. And so what would I put on top here? And what would I put in the bottom here? For sure. What would I put?
Yeah, put dV on top and dH on the bottom.
Good. And then we're looking for some other parameter. That's what we're looking for. Now, when you look at this, right? We have volume and height here. What other parameter do we have?
dt.
We have dt. We have the change in time. So I could put dt over here, and I could put dt over here. So look at it for yourself. Wouldn't this give you dVdh? Wouldn't that give you dVdh?
Yes, sir.
It would, because the dt and the dt would cancel off, and that would give you dv over dh. Bam. Make sense?
Yes, sir.
Right. So that's the whole premise of connected rates of change. You want to connect different rates of change to get another rate of change. That's the whole concept. So
Wait,
I'm gonna
quick question. Sorry.
talk to me, Jenna.
You have dt over dh, but you also have dh over dt. Are those the same or like?
Okay, so you bring up a good question. dt over dh is the reciprocal of dh over dt. So let me explain, right? If dt was equal to, say, 5, then dt dh would be equal to what? What do you think?
-5?
No?
Oh no, 1/5.
1/5, yes. Let me explain that one more time. So guys, if the change in height with respect to time was 5, now 5 is the same thing as 5/1. You agree? Same thing as 5/1?
Yes, sir.
Okay. Then dt dh, I'm not sure if you see, but dt over dh, you just flip it. You just
Flip it,
reciprocate it. And so you would do the same thing on the other side. So if I flip 5/1, what's that gonna become?
1/5.
Bam, 1/5.
Yes, sir.
So it's not the same thing, it's just the reciprocal. I wonder if you catch that.
Yes, sir.
All right, badness. So I'm gonna throw you guys straight into the pits of hell. Let's go. Fun stuff. So Jenna's gonna start us off with question 1, warm up. So Jenna, give that a read for me.
A metal cube is heated so that each edge expands. The length of an edge is x centimeters and the volume of the cube is V equals x cubed centimeters cubed. The length of each edge is increasing at a constant rate of 0.2 centimeters per second. Calculate the rate at which the volume of the cube is increasing at the instant when the edge length is 5 centimeters.
Okay, that's something a little complicated. What do you think? A little
Yeah.
complicated? All right. So let's examine what's happening. They're telling us a metal cube is heated so that each edge expands. You understand the physics behind that, by the way?
Yeah, because it's metal and when it's heated, it expands.
It expands because, like, when you heat the metal, the molecules inside, they gain kinetic energy and they're going to start to vibrate more meticulously and they're going to start to hit the inner surface of the metal cube. And that's going to push against the metal cube, exert enough force on it, and that's going to cause it to, like, expand because it's pushing against the walls.
Okay. So I never did physics before in my life, so like this is kind of new.
You never do physics.
No, I didn't. I don't have it as a subject, so
Oh, okay, I see, I see.
yeah.
So just from reading that line, we could figure out that we have a cube, right?
Yes, sir.
Okay, we have a cube. So give me 1 second, I'm gonna put a cube here. Virginia, you getting enough rest?
Yes, sir. I'm sorry about earlier.
That is okay.
Yeah.
Like you needed a rest.
Yes, sir. It was, yeah.
Yeah, boy.
Did you get enough rest?
Yeah, I get enough rest,
Okay, okay.
right? So, Jenna, you understand how we have a cube, right?
Yes, sir.
And they're saying the edge expands. What do you call what do you want to call the length of each edge?
X.
Yeah, you could call it X, so we could call each edge X. It's not a problem. Nice. And they're telling us that as you heat the cube, what happening? As you heat the cube, what happening?
It expands.
Exactly. So
Okay.
you could so you tell me something. X is changing with respect to what? You tell me.
I was
X would
gonna
be
say,
changing.
why.
No. Talk to me.
Um,
As you keep heating the metal cube, right? What passes by? As you keep heating the metal cube, what
the
passes
volume.
by?
Volume.
No. Okay, you're heating the metal cube. Let me just say I start a watch, right? I start heating it. As the time increases and it gets heated more, what happens?
It expands.
Right? So what will expand?
The length.
The length. So the length is changing with respect to?
Time.
Yes, with time. All right, so imagine this. You start, like, at time is equal to 0 seconds, the metal cube just there. But as the time increases and it's exposed to more heat, it's going to expand more. So the whole thing I'm trying to say is the length is changing with respect to time. Understand?
Yes, sir.
All right, cool. So the length is changing with respect to time. Hope that makes sense. Because the longer you have it exposed to heat, the more the cube going to expand. You understand?
Yes, sir.
All right, cool. So they're saying the length of an edge is X centimeters. We figured that out. And the volume of the cube is V is equal to X cube centimeter cube. So they're telling us that volume is equal to X cube, right?
Yes, sir.
All right. Now I have a question for you. If, when you heat it up, the edge is expanding, what would also expand? Like, okay, sorry, what would also increase? What would also increase?
The volume.
Yes, the volume would also increase. Yes. So the volume would increase with respect to time, and the volume would also increase with respect to what? You tell me. See if you can figure this one out.
You
So the
said
volume gonna, yeah,
the
tell me.
volume increase with respect to time.
Yeah, that's one. The volume would increase with respect to time. What else would the volume increase with respect to?
The volume will expand in respect to height.
In this case, well, it's a cube, right? So each dimension is the same, has the same dimension. Well, has the same length. So I think you should say the length. So the volume
Oh, okay.
is with respect to the length. Because talk to me, right? Look at this. Look at this example. Let's just say you have this, and I'm gonna blow it up, right? As X increases, what happens to the volume? As X increases, what happens to the volume?
The volume also increases.
Exactly. So maybe at some point you might have to look at dVdx. You understand?
Yes, sir.
Because you see for yourself, as X increases, the volume gets bigger, so it will occupy more volume. All right? Cool.
Okay.
So they gave us volume, cool. Then they're telling us the length of each edge is increasing at a constant rate of 0.2 centimeters per second. So Jenna, what is that? What is that they just gave us? Hmm. The length of each edge is increasing at a constant rate. And you're seeing 0.2 centimeters per second.
Second. So,
Hmm.
so dl over dt.
Right? dl over dt. But instead of L, what are we using? What are we
X,
using for the length?
X.
Yeah? So I could say dx dt, right?
Yes.
Let me go over that one more time so everybody stays with me and understands. So they're saying the length of each edge. So we're talking about the length of our edge, right? What are we using for our length of our edge? What are we using for our length of our edge?
X.
We're using x, right? So
Yeah.
x is changing with respect to what?
Time.
Per second, but right, time. So when you look at the units, you should be able to figure it out as well. Centimeters is for our length. So centimeters is for our length. We measuring the length using x, and then you see in per second, so like time. So that'll be dx over dt. You understand?
Yes, sir.
Good. Good. Happy to hear that you understand. Right, so we have dx dt. So dx dt is actually equal to what? What is dx dt actually equal to?
0.2.
That's actually 0.2, right? And they want us to calculate the rate at which the volume of the cube is increasing. So what do you think they want us to find? Again, you're seeing rate. Anytime you see rate, we should think about already.
Time.
Right? Anytime you see rate, guys, rate is with respect to time. So that is dt. And then you're seeing what over there?
The volume of the cube is increasing, so dt over dv.
Take your time. Remember what I tell you. If you say
sorry.
dt over dv, that means you're saying the time change
Time
with
in
respect to
respect to
volume.
volume. Yes, so it's the other way around. So
That makes
dv
sense.
over dt.
Right? So they actually want us to find dv dt.
Yes, sir.
So at the instant when the edge length is 5 centimeters, so let's handle this. Let me ask you a question, right? If you want to find dv dt, that's what you want to find, then you know you have to multiply two different rates of change to get that.
Yes,
What would
sir.
go here for sure? What would go on top for sure?
dv.
And what would go in the denominator for sure?
dt.
For sure. And now you're going to look for any other parameters you have in the question. So you have volume and time there. What other parameter do we have?
dx.
Exactly. So we're going to put dx here, and we're going to put dx here. Here's a little hint, Jenna. You notice how they gave us dx dt?
Yes, sir.
I know dx going to come here because I got to put dx dt. And if I could figure out that dx
Yeah.
going here, and it would go here as well?
Yes, sir. Because they have to cancel.
Right. Exactly. So I have dx dt. Dx dt is that's actually 0.2. However, I don't have dv dx. I have to find that. How am I going to find dv dx?
You have to differentiate the volume, which is
With respect to
with respect to time. Yeah.
time. Let me ask you a question. You seeing any time over here?
Oh, with respect to x.
Exactly. You could only differentiate a function with respect to the variable in the function.
Yes,
Yeah.
sir.
So that's dv over dx. So anybody that's confused, when you're differentiating, you're going to multiply by the power and then minus 1 from the power. So tell me, Jenna, if you
3x
differentiate that, right, you get 3x squared. So you multiplied everything by 3 and then you took away 1 from the power. So 3x squared. Nice. So dv dx, that is 3x squared. And you're multiplying that by what? What is dx dt?
0.2.
Bad. And so in the question, they said at the instant when the edge length is 5 centimeters, right?
Yes, sir.
So what am I going to use for x?
5 centimeters.
Correct. I'm going to use 5. So I'll say 3 by 5 squared multiplied by 0.2. So you can plug that into your calculator and you'll get your answer. So do that for me.
6.
Wait again?
6.
6?
Yeah.
Okay, what about the rest of you guys? Did everybody else get 6? Let me know if you guys got 6.
I
No,
got
I calculated it wrong.
15.
It's 15, yeah. I calculated it wrong.
You calculated wrong, it's 15.
Yeah, it's 15.
Yeah, I got 15 as well.
Okay, nice. So here's what. Now we have to put the units. So Jenna, we are finding volume with respect to time. Okay? So what's the unit for volume? If our length is centimeters, what would the unit for volume be?
Cube?
So what's
Centimeter.
cube?
Centimeter.
Centimeter cube. And you see in divided by time, so it'll be what?
Centimeters per second. I mean what?
Right.
Second, yeah. Yeah, that.
Centimeter cube per second.
Mhm.
You can write it like that, or you could write it as 15 centimeter cube s to what power?
-1.
Right. Cool. That's it. Now, let me show you a way that you could figure out the question without analyzing it so much. But like, I just wanted it to make sense for you. So
Yeah.
let me run it through one more time. So Jana, if I tell you a metal cube is heated so that each edge expands, it means that as time passes and it gets more heat, what do I mean?
The length expands. The
Right,
edges.
the length is going to increase. So in that instance, the length is increasing with respect to what?
Time.
Good. Cool. That's one rate of change. And so
Cool.
let's see. Then they're saying the length of an edge is x centimeters. And the volume of the cube is V is equal to x cube centimeter cube. So what do they want you to call the length? What do they want you to call the length?
X.
They want you to call the length x, correct? So
Okay.
it's going to be dx dt. You understand?
Yes, sir.
So in the second part, they're saying the length of each edge is increasing at a constant rate. I'll read that one more time. The length of each edge is increasing at a rate. So length of edge, that's x. Rate is time, like dx dt.
Yes,
And you
sir.
can see that from the units, because you see in centimeter per second. Centimeter, by length, by x. And s minus 1, by time. So dx dt. Right.
Yes, sir.
So dx dt is equal to 0.2. Cool.
Okay.
I
Yes.
write that down one time. I say dx dt is 0.2. Cool. Then they're telling us to calculate the rate at which the volume of the cube is increasing. You see any word rate. Rate is always with respect to time. And you see in volume. So volume is changing with respect to time. So that's dV. So put that together and the way to find what? What the way to find?
The rate at which the volume of the cube is increasing
With respect to?
with respect to time.
Exactly. Cool. You with me so far?
Yes, sir.
All right. So the way to find dV dt. So immediately you're gonna come here and you're gonna put two fractions and you're gonna put a multiply sign. You understand?
Yes, sir.
If you want to get dV dt, then you know you must have a dV on top there, and you'll need to have a dt in the denominator there.
Yes, sir.
Now you're looking at what they gave you. Didn't they give you dx dt?
Yeah.
So wow. And if I have dx over here, we have to put dx over here too.
Yes, sir. So because they have to
And-
cancel.
Exactly, and that means we have to find dV dx. So what formula are we going to look at now to find dV dx?
The volume equals x cube, and you have to
Exactly. And we're going to differentiate V with respect to what?
with respect to x length.
Exactly. Good. And we're going to get 3x squared. So we know what dV dx is. dV dx is 3x squared.
Yes, sir.
So that's 3x squared by 0.2. And they told us at the instant when the edge length is 5 centimeters. So x then would be equal to what?
5.
Exactly. So I'm going to replace x with
5.
And yeah, you just get your answer from there.
Yes, sir.
You okay with that?
Yes, sir.
So again, here's the strategy. All of you guys gonna perform. So Jenna, Kamaya, Sachin, Virginia. Hey, what you gonna do, right? You're looking for what they give you. In this question, they give you dx dt. I write that down. Yeah? dx dt. Then,
Yes.
then you look out for any formulas they give you, like volume, area, whatever. That is very important. Chances are you'll have to differentiate that. Then you're going to look at what the way to find. So if they want me to find dV dt, then you kind of set it up using that information. And again, you might have to differentiate the formula they give you. So I'm going to give you all 5 minutes to attempt this question. Take 5 minutes and attempt this one. So Jenna, you think you could do it?
I'll try, sir.
Don't say you could try. Say you will. Say
I
you
will.
will.
Yes, sir.
Right, you will. Advanced people, let's be so rare though. Like, I don't know. Like, there's hardly have anybody else who admats. But admats so much more fun than regular maths. So
So the class, my admath class in school is only 7 people. Yeah,
7
out of the entire Form 4 year group, Form 5, sorry, year group.
7 people.
Yeah.
That is crazy. That is genuinely crazy. How is it just 7?
I have no idea. My teacher said that she's scared that there's gonna be nobody for admaths next term. Well, this term coming, so. Yeah.
Wow. You know, the first subject I started to teach was art maths.
Oral.
Yeah, I had one student. All right, so 3 minutes remaining. Hey, good night, good night. So like 3 minutes remaining. Then we'll correct it. Why nobody is do add maths for, boy? Why nobody is do add maths? Add maths is peak. My God. So Kamaya, would you like to do this question with me?
I'm not getting through, but yeah, I could do it with you.
All right, you're getting through. Sachin, you're getting through. Well, Sachin, I have no doubt you're getting through. You got the hard question correct in class.
Well, yes, yeah, okay, correct. I think.
Virginia, I have no doubt you get it correct as well. Talk to me.
So you should have doubts. I'm kind of confused. Like
You
for what?
confused?
A bit, yeah.
Okay. So Jenna and Virginia, you guys will help me with this question. So you'll have like 1 minute remaining, and then we will correct it. So Virginia, what are you confused about?
Maybe how to approach it because it's a different scenario.
It's the same kind of thing though. Let me explain. So read the question for me, Virginia.
Okay. Oil leaking from a tanker forms a circular slick on the surface of the sea. The slick remains circular and its radius, r centimeters, increases at a constant rate of 3 centimeters per second. The area of a circle is given by A is equal to pi r squared. Calculate in terms of pi the rate at which the area of the slick is increasing at the instant, where the radius is 8 centimeters.
All right. So Virginia, imagine you have a tanker, right? You know that tanker?
Not quite sure. It's like a boat on the sea or something. I don't know.
I think it's like a war, it's like a war, like you know those like war things.
Or like those warships. Or I
Oh
don't
no,
know.
no, my bad. It's not a warship. This is a tanker.
Oh, yeah, I didn't know that.
Right. So here what? Let me explain the scenario for you.
Okay.
Imagine that you have a tanker here and it's stationary, right? Like it's stationary on the sea. You with me?
Yes, sir.
and there's a leak. Now that leak is going to fall, and it's gonna like the more oil that leaks is gonna form a circle.
Yes, sir.
Like, okay, think about it. Like if you pour water on the ground, wouldn't it like spread out and form a circle like a puddle?
Yes, sir. It would. I'm kind
All
of
right, so
visioning.
so that's the scenario, right? You have an oil tanker and that is leaking. So that's leaking and that's forming a circle. You understand that?
Yes, sir.
All right, cool. So they're saying the slick remains circular and its radius r centimeters increases at a constant rate of 3 centimeters per second. So Virginia, think about it. Think about it, right? If you keep pouring water, well, in this case, if the oil leak continues, then more oil is gonna leak and it's gonna increase the what of the circle. What's gonna increase for the circle?
I don't know. Could it be the radius?
It is the radius. Watch that was the radius before, and if it keeps leaking, the radius increases. You can see that,
Oh yeah, I'm seeing it now.
right? So as time passes by, what is increasing?
The radius with respect to time, so dRdt.
Exactly. So just from this statement, so like as soon as I read this, they're saying the slick remains circular and its radius increases at a constant rate of 3 centimeters per second. When I read that, right, I could figure out that the radius is changing with respect to time at a rate of 3 centimeters per second. And what that means, Virginia, is that every second that goes by, the radius increases by what?
3 centimeters.
Yeah, exactly. You okay with that?
Yes, sir. I'm fine with that.
Jenna, were you able to figure that out? That the first line over there is dRdt.
Yes, sir, I got that.
Cool. And even if you have some doubts, right, Virginia, you're seeing centimeters over here. What would we measure in centimeters?
A length, and in this case, it's a circle, it'll be radius.
Is the radius, right? Radius. And you see in per second. So that means with respect to time. So that's dRdt. So dRdt is 3 centimeters per second. So the radius is changing at a rate of 3 centimeters every second. You okay with that?
Yes, I'm okay.
Cool. So I'm gonna write that down one time. dRdt is equal to 3 centimeters. Oh yeah, you wasn't there any class this morning, so that's why you're confused.
Yeah, I'm just like using my knowledge from the live from before. You know, your
I
live
see.
for TXE. Yeah.
Yeah. All right. And then they give us a formula. You always want to put down the formula they gave you. Virginia, think about it. As time increases, the radius will increase, but what will also increase? The what of the circle?
I want to say volume, but I feel like that's wrong. I don't know.
Is a circle. A circle is what kind of shape? A 2D shape, a 3D shape? What kind of shape is
Oh,
a circle?
2D. 2D.
A 2D. Can you find volume of a 2D shape?
No. So area?
Ah, area. Yes, watch.
Okay.
Can you see that the area increases? Like if the oil keeps dripping, the puddle is gonna get bigger and bigger and bigger. So the area it occupies is gonna become more. So can you
Yes.
see that?
Oh, yes, sir. I see it now.
So what is changing?
Um,
Summarize it. Just tell me. So summarize it. What changing? You seen it? What changing?
the area,
With respect to?
time.
Right. Cool. And wouldn't the area also change with respect to the radius?
Yes, sir, because as the radius increases, the area does as well.
Exactly. Look at the formula. Like if you use a bigger value for R and you get a bigger answer for area.
Oh, yes, sir.
Yeah. So like from this, we could analyze a couple things. We could see that as time passes by, the radius is going to increase. Seeing that?
Yes, sir.
We could also figure out that as time passes by, what increases?
The area with respect to time.
And we could also, this one kind of hard to see, right? But like you told me, as the radius increases, what increases?
The area as well.
Right, so that'll be dA, dr. Badness. Say with me?
Yes, I'm with you.
And in the question, they gave me the formula for area of a circle. So A is equal to pi r squared. So I'm going to put down that formula. A is equal to pi r squared.
Could we differentiate like d over dr?
Exactly. So that's actually, you'll see what that builds up to, right? We'll give me a second. So
Okay.
analyze it. So Jenna, you have everything I have so far?
Yes, sir.
Come on, yeah, Sachin, like all you're good, right?
Yes, sir.
Yes, sir.
Right. So Virginia, you're always gonna put down what they gave you. You're gonna write the formula that they gave you, and then you're gonna look at what they were to find for. So Virginia, let's see and calculate in terms of pi the rate at which the area of the slick is increasing. So anytime you see rate is always with respect to what?
Respect to time.
And they're saying the area. So that is dE, right?
Yes, sir. So it'll be dA over dt.
Exactly. They want you to find dA dt. Now, how would we do that, boy? Well, let me think, right? You know you had to connect two different rates of change. So like, I'm going to put on two fractions. And so if I want to get back dA dt, what would I have to put here? And what would I have to put here?
So dA will be on the top and dt below.
Right. So now, here's the fun part. Look at the question. Look at what they give you. What they give you? What did they give you earlier?
They gave us dr dt, so we could put down
Bingo.
dr on both sides.
Bingo. Jenna, let me know if you got that. Like they gave you the RDT, you know. So if they give you the RDT, we could actually put it over here in the RDT. And if
Yes.
that is DR, that's how to be DR as well.
Yeah.
You was able to figure that out?
Yes, sir.
Okay, cool. So, Virginia, we have to do what now? Like we have the RDT, you know, the RDT is 3. Well, it's hard to find.
So you have to find dA dr. So you'd have to differentiate A with respect to r, area with respect to radius, I guess. Yeah.
Right? Yes. And what would that be?
Would it be 2 pi r?
It would be 2 pi r. For anybody that's confused, anytime you have to differentiate something like this, you are going to multiply by the power. So that's going to be 2 pi r, and then you're going to take away 1 from the power. So 2 minus 1 is just 1. So that's just r to the power 1, which is just r. So
Yes.
Virginia, we know that dA/dr is 2 pi r. So dA/dr is 2 pi r, and we're multiplying that by dr/dt. dr/dt is 3.
Yes, sir.
So we're going to get 6 pi r. Now, in the question, they said at the instant when the radius is 8. So what do you think we have to do to finish up the question?
So replace r with 8. So 6 pi by 8. So that'll be 6 by 8 pi, which is 48 pi.
Good. And you want to look at the units carefully. So it's area with respect to time. Area with respect to time. So talk to me.
So that'll be centimeter cube per second, because area is centimeters cube. Wait, no. Yeah? I don't know.
All right, let me think about it, right? So Virginia, when we talk about area, how much dimensions you typically think of? Area.
1 dimension. Wait, 2D, 2 dimension. Oops.
2 dimensions. Like, let me ask you a question, right? What shape is this?
A rectangle.
How much dimension does a rectangle have?
2 dimensions. Oh,
Right. So if it's 2 dimensions, then it's going to be squared. If it's 3 dimensions, it's going to be cube, right?
okay. So that's why 3D is like centimeters cube.
Yeah, that is
Okay.
why. And that's why area is,
Centimeters squared. Okay, I see. Thank you, sir.
right? No problem. So area, that's centimeters squared per what?
Per second.
Right, per second. So you can write it like that. Or if you want, you could write it like 48 pi centimeters squared s minus 1.
Thank you, sir. I finally understand now.
Nice. So that's the tactic, right? You want to analyze the question. You want to see what they gave you. You're going to write down what they gave you. They gave us this, right? Then they gave us a formula for area. You write that down. I bet you got to differentiate that. Just keep that in mind. You got to differentiate that at some point. Okay?
Yes,
Then
sir.
you want to look at what they want you to find. In this case, they want us to find the rate at which the area is increasing. So that's dA dt, because the area would change with respect to the time. So if I know they want me to find dA dt, then I'm going to put dA on top here, and I'm going to put dt on top in the bottom there. Then I'm asking myself, are there any parameters again? Well, if you look in the question, they gave you dr dt. So I know dr going to go here. And if dr goes there, then it has to come over here as well. So you have dr dt. Dr dt is 3. The only thing you have to find for now is dA dr. So you have to differentiate this with respect to radius. You're going to get 2 pi r. So 2 pi r by 3, that's 6 pi r. And we know that the way to find is when the radius is 8. So we have to plug in r for 8, and you get 48 pi. And you're probably wondering, well, sir, why those units? Well, it's area with respect to time. We measure area in centimeters squared because there's 2 dimensions for areas, centimeter by centimeter. And with respect to time, it's just per second. So you fully understand?
Yes, sir, I do. Thank you so much. I feel like it was this scenario confusing me because I didn't know it was an oil tanker. So it was like, oh, yeah.
Do you understand it now?
Yes, sir, I understand completely.
Okay, cool.
Excuse me, sir.
Right. Talk to Makamaya. Let me know if you got through.
Yeah, I got you, but I wanted to know. I know you went through all you said some stuff, but I wanted to know, like, if you could write like generalized stuff for like all questions, or that's not possible for these types of questions.
It could be generalized, but I would like you to think as opposed to just memorizing and procedure. But like,
It's not really for memorizing. It's just to make sure, like, I'm going on the right stuff.
all right, so you want to, okay, you're gonna look for what they gave you, right? So write down. So you want to write what was given. Write what was given. That's what you want to do. Write what was given. And you go in, or like just know, anytime they give you a formula, whether this formula is area, but they're gonna give you a formula, right? This formula might be area, this formula might be volume, whatever. Just note that you might have to differentiate that, right? Hold that in mind, keep that in mind. And then the last thing you want to do is you want to look at what you have to do. So you're gonna look at what they are asking. What are they asking? What are they asking? That's the question. And from that, you could use the chain rule to connect the different rates of change. You understand?
I keep saying chain room, but like, how is that chain room? Oh,
Okay.
wait. Never mind.
You see this? This is chain rule.
Yeah.
So what are they asking? So you're gonna use chain rule. You're gonna use chain rule to connect the right. So that's pretty much what I would advise you to do.
So,
Talk to me,
Uh,
Sachin.
it have a other way to do it without chain rule, or no? You could only use chain rule.
To my knowledge, chain rule is like the only way you could do it.
Okay.
Yeah. All right. Okay, cool. So we're gonna move on now. All right. So Kamaya, actually, Virginia, I want to do an next question with you.
Okay, sir.
Right. So Virginia, give that question. I'll read for me.
Okay, a circular metal disc of fixed thickness 4 centimeters is heated so that it expands outwards. The thickness stays the same, but the radius r centimeter increases. The volume of a cylinder is given by V is equal to pi r squared h. The volume of the disc is increasing at a rate of 96 centimeters cubed per second. A, show that V is 4 pi r squared. B, hence calculate in terms of pi, the rate at which the radius increases. Is increasing when the radius is 3 centimeters.
All right, so Virginia, in the question, we have a circular metal disc, and they're saying it has a fixed thickness of
4 centimeters.
right. So let me just draw that for you. So I'd try my best to draw something there, right?
It's
Let me
fine.
just say, and we know that it has a fixed thickness of 4 centimeters. If it have a fixed thickness, will that ever change?
No, so it would remain constant.
So that is a constant in this matter. So the thickness is always 4 centimeters, right?
Yes, sir.
But they're saying when it's heated, it expands outwards. So if it expands outwards, what would change?
I want to say the volume, but I don't know.
The volume would change, yes. That's one thing that would change, yes. What else would change?
Would it be the radius because it's a circle?
Exactly, like if it expands outwards, the radius is going to increase.
Oh, yeah.
So, Jenna, you understand what I'm saying so far? Like, if you had a circular metal disc and it has a fixed thickness of 4, then if it's a fixed thickness of 4, will the thickness ever change, Jenna?
No, because it's fixed.
Exactly. So, what would change though? What would change about the circle?
It would expand like outwards.
It would expand outwards. And if it's expanding outwards, then what are the main things that are going to change as a result?
The radius.
The radius. And if the radius is changing, what else is going to change?
The volume.
Yes, the volume. Because I'm asking that question, Jenna. Isn't volume of a cylinder pi r squared h?
Yes, sir.
So if you use a bigger value, if you use a bigger value for radius, what happens to the volume?
It will change. It would be bigger.
Exactly. Like, okay, if I use 1 squared, I will multiply everything by 1. But if I use 3 squared, I will multiply everything by 9. So the bigger the value for radius, the bigger the value for volume. You
Yes, sir.
understand?
Yes, sir.
Because we're going to multiply r squared by pi and h. So that directly affects volume.
Okay.
So just from looking at the question, guys, we know that the thickness is constant, but what are the things that are changing?
The radius and volume.
The radius and volume. Yes. So I could say dv dt. I could say dr dt. And would you all agree with these things? These are things that are changing.
Yes, sir.
Yes, sir.
One other thing is changing though. Let me see if I can figure that out. Let me see.
Could it be DVDR? Because as the volume changes, the radius also does.
I think you meant to say the other way.
Oh,
Because the radius is changing, the volume would increase. Yeah.
oh, sorry. Yeah.
That's all right. So Jenna, I wonder if you understand what I'm saying so far.
Yes, sir. I understand.
Cool. So that was just an analysis, right? So let's look at what formula is given. They're telling us that the volume of a cylinder is V is equal to pi r squared h, right? V is equal to pi r squared h. And they're telling us the volume of the disk is increasing at this rate. So, Virginia, what would that correspond to? What would that be?
DVDT.
That would be dv dt, yeah?
Yes, sir.
And dv dt, that means that the volume is changing with respect to time. And so that's going to be 96 centimeter cube per second. So, Jenna, you with me so far? You're confused.
No, sir. I understand. I think.
You think. I don't like that. I think, As soon as I hear that, I think I get scared.
Yeah, I understand.
Explain it to me.
Well, they said the volume of the cylinder is the volume of the disk is increasing at a rate of 96 centimeters cubed per second. So that means the volume is increasing with respect to time, therefore dv dt.
Yes,
is-
that's correct. So I'm gonna write that down, guys. Gonna write that down. Yeah. So dv dt is equal to 96. I just can't put 96 for now. Cool. So in the first part, Virginia, they want us to show that the volume is always going to be 4 pi r squared. How I could show that, Virginia?
I'm not sure. I want to say differentiate, but it says V, so I don't know.
No, Virginia, don't say you don't know. Like, you could figure this out. Virginia, tell me the facts. Tell me the facts. Like, what you know about the circular metal disc,
It has a fixed thickness of 4 centimeters.
right?
The thickness stays the same, but the radius increases.
Okay, and the way to show that volume V is equal to
4 pi r squared.
right. What's the original formula for volume?
Pi r squared. So we had to prove that the height is 4.
Wait, no. The original volume is pi r squared h, right?
Yes, sir.
What does h correspond to for the metal disc?
Oh, would it be the fixed thickness?
Yeah.
Oh, okay.
So what would you do?
So replace h with 4 and plug it into the equation.
Yep. And that's what you
Oh,
get.
okay. I understand now.
Wait, so I have a quick question.
Talk to me.
The 4 centimeters, that's the height. But we wouldn't use that for anything in this question because it's fixed, so it's not changing.
Well, we would actually use it. Let me
Oh.
explain, Jenna. The height is constant. The height is constant. So, like, instead of saying pi r squared h, we could just say 4 pi r squared. That's the formula we'll use for volume. Because the height is a constant, so it'll just be 4 pi r squared. The only thing that will affect the
Oh.
volume, Jenna, tell me, what's the only thing that's gonna affect the volume here? 'Cause the height constant, so what's the only thing that could affect our volume?
The radius.
Exactly. So we end up with a formula for volume, where the only variable being what? What's the only variable?
4. 4.
What is not a
Wait, when
variable?
you say variable, we mean like
Okay, so a variable is a letter, meaning that you could plug in a different input. So like
so the height then. Because that's what they gave us for to be.
height can't change. Remember, the height is a fixed thickness. The height cannot change. What is the only thing that could affect the volume?
Or the radius.
Exactly. So that's why we come up with a formula for volume in terms of the variable what? Okay, so like the variable is something that changes.
Okay.
So like,
okay.
Thelma, what do you think would, so you tell me, right? What would affect the volume?
The radius.
Exactly. So what's the variable there?
R.
R. Exactly. So can you agree that as the radius changes, it affects the volume?
Yes, sir.
So the radius then is the what?
Variable.
Exactly. You
Okay.
understand?
Yes, sir.
You sure you understand?
Yes, sir, I understand.
Okay. Good. So let me explain that again. So talk to me, right? You were telling me earlier.
I was asking about if like we would use the height for anything earlier, but I understand. Oh,
You would plug in the height. The height is a constant thing.
okay.
You understand? Like the height not changing, no?
Yes, sir, because it's fixed.
Exactly. So that I plug it into the formula and I get 4 pi r squared.
Yes, sir. Because they said
Say that again?
no. I was saying I realized that they asked to prove it, basically like a proof. That's why
Yes.
they got the 4 pi r squared.
Mm-hmm. And was the only thing that would affect volume in that instance?
The radius.
Exactly. So what's the variable there?
The radius.
Exactly. So let's answer part B now. All right. So Virginia, read part B for me.
Hence, calculate in terms of pi the rate at which the radius is increasing when the radius is 3 centimeters.
All right. So they want me to find the rate at which the radius is increasing. What is that they want us to find?
So since they mentioned rate, it would be respect to time, so dr dt.
right? That's going to be dr dt. So how would I find that? So dr dt.
Okay, so we know that dr would be on top on the left hand side and dt would be below on the right hand side.
Do say left hand side and right hand side because
Oh, sorry.
all of this is on the same side. So say
Oh, that's
dr would be on the numerator and dt would be in the denominator here.
okay. Sorry.
And what did they give us earlier?
They gave us volume. Well, they gave us dvdt. Sorry,
Aha, so what am I going to put here?
dv.
Right? And if I put dv over here, what am I going to put here?
Also dv because they need to cancel, right?
Yeah. And so you realize that we have dv dt here, we have dv dt, but now we have to find dr dv. How am I going to
Yes.
find dr dv? It's a question.
So I would say that we differentiate dv dr and then just write the reciprocal.
Yes. So are we going to differentiate this or are we going to differentiate this?
I would use the second option because you plugged in h already.
Exactly. You plugged in h already, so you'll use that one. So let's do that. So that's going to be dv. So v is equal to 4 pi r squared. Right? And we want to find for dv dr first. So we're going to differentiate volume with respect to radius. And what would you get?
I would get 8 pi r.
All right, 8 pi r. Nice. And so we could plug that in. Not yet, eh? Not yet. We have to do what? So right now is 8 pi r over 1. So if you wanted to get dr dv, what would that be?
1 over 8 pi r.
Dr dv would be equal to 1 all over 8 pi r. So that's going to be equal to 1 all over 8 pi r multiplied by what?
Multiplied by 96 centimeters cubed per second.
Right? So you're going to end up with what?
Wait, wouldn't we have to plug in 3 into the equation or no?
Yeah, we'll have to do that part. We could always do that to the end.
Okay. So 96 divided by 8 is 12. So 1, 12. Okay.
Right?
Well,
And what is r?
so r is 3.
Mm-hmm.
So 12 over 3 pi. And I believe that can be reduced to 4 over pi.
Yeah, 4 over pi. So that's going to be 4 over pi and the units. Let's look at the units. What would the units be?
Okay, it's dr dt, so centimeter per second.
Yep, centimeter per second. Jenna, were you able to get that one?
Yes, sir. But yeah, I was kind
Yeah,
of working
sure.
it at the same time as you, but yeah.
You're sure you was able to get that?
Yes, sir.
Okay. Sachin, what about you?
Yeah.
So you got 4 over pi, right?
Yes, sir.
Okay, cool. Right, so we're gonna move on, and I'm going to give you all 4 minutes to try. Actually, take 5 minutes and try to do that. Try to do question 4. Try to do question 4. Let me see what I can figure that out. I don't know why not much people do hard maths, but Watch out when we start maths, the like numbers go real increase for the live, eh?
Oh yeah, because the ad mass people rare.
Yeah. We're just built different.
Yeah, extraordinary.
Yep.
Guy. But then it got boring. So today we're going to be doing something different. What is it with people please tell me about? Today I'm going to create space for short, but you can just go and follow. I mean, everyone does. Today I'm going to be doing my best friend to try to every single fight. Yeah, that trying to without 5 feet. So be my eyes.
So when they say inverted circular cone, is that like indicating like the height, like how tall it is?
Yeah, but don't let it affect you too much. It's just a circular cone upside down. That's all.
Oh, okay.
Like, don't let it confuse you.
Yeah, because I see it's like with the 20 centimeters cube, so that's what I thought about it.
The whole point is that it's a cone. That's the whole point. That's the whole point is a cone. So whether it's upside down, inverted, upright, still the same thing, right?
Oh, yes, sir.
Just upside down. At the end of the day, it's still a cone. Oh, you know, Romano, how about YouTube channel?
Really? What does he post?
Like he's insane. He posts on Minecraft stuff.
Oh, that's pretty cool.
Mm-hmm.
But I'm pretty lost again.
I see. Try to figure it out. After the time's up, then I'll give you some assistance, but try to figure it out.
Okay.
Yeah. Oh, look the lights. The lights changing colors.
Oh wait, that's cool.
I'm turning back to blue. All right. Oh, now watch any chat. There's this person whose name is a dot. DDT both sides and solve for the RDT. Yeah, that's a feasible method. Would you guys like to see an alternative approach to solving this, Sachin?
Sure.
I'll let you guys finish with this first, but there's an alternative approach you could take. So, but I think this is the easiest way you could do it. But there's another way you could do it.
So is this like basically physics?
It is physics. Like you use odd maths in physics all the time.
So then students who don't do physics are kind of at a loss, right?
They're not that much of a loss. Like you could do this question without understanding anything. Like if you follow the algorithm, like the hack, you're gonna get your question correct anyways. I'll show you. Like
I know what the question is, like the analyzing that keep making me mess up. Because like reading it, I'm like, okay, I'm trying to like work it out, if that makes sense. Like the question not making sense to me.
even if the question doesn't make sense, if you follow the steps, you would get your answer. But I'll try to explain it to you though.
Okay.
But that's the thing, as you go higher, like the deeper you go into maths, the more abstract it becomes. And at some points in time, you just have to like, okay, accept that you wouldn't understand everything completely.
Mm.
And yes, it is implicit differentiation, right? So I'll still show them. They'll learn that in upper six, but I guess some of them might appreciate it. Right? Okay, so Jenna, Virginia, I'm going to do the question first without digging too deep into it, right? That's what I'm gonna do. So Jenna, let me show you how you could figure out the question without digging too deep into it. So in the first part, they say you're pouring water. Water is poured into an inverted right circular cone at a rate of 20 centimeter cube per second. Or yada, yada, yada. All that means is that this over here is dV/dt. You understand?
Yes, sir, I got that.
Right? So dV/dt is equal to 20, right? I forget any units for now, but dV/dt is 20. Virginia, let me know if you understand that.
Yes, I understand that.
Okay. And they're saying the shape of the cone is such that at every instant, the radius of the water surface is half the depth of the water, that is, R is equal to H/2. So they're saying the shape of the cone is such that at every instant, the radius of the water surface is half the depth of the water. And that part probably confused a lot of you guys.
Yeah.
Okay, so let me explain. I got how to do some sort of explanation, right? Here what? I'm gonna do the question first without digging too deep into it, and then I'll do the explanation. But I'm just crunching the numbers with you guys for now. So we know that dV/dt is 20, and we also know that R is equal to H/2. Let's just take that as is right now. R is equal to H/2. Are you with me so far?
Yes, sir.
Right? And they're telling us that the volume of the cone is given by V is equal to 1/3 pi R squared H. So that's given to us. In the first part, they want us to show that V is equal to pi H cube all over 12. So if we just crunch the numbers, then the first thing I want you all to observe is the absence of what in this. What I want you all to compare these two. What does one have and the other doesn't?
The radius squared.
Exactly. You're with me, right? One has radius and the other doesn't have radius at all.
Yes, sir.
So Jenna, Kamaya, Sachin, if we are thinking analytically, right? And you're comparing this one to this one, the first thing you want to understand is that A, it does not have R in it. So if there's no R in that, maybe we might have to do a substitution. So Virginia and Jenna, Kamaya, Sachin, anywhere, did you see a part where they replaced H for something? I mean, sorry, we replaced R for something?
Yeah, H/2.
Right, R was equal to H/2. So if we look at the original formula was V is equal to 1/3 pi R squared H. Then we could actually replace R with what? What could we replace R with?
H/2.
Jenna, Kamaya, Sachin, isn't R equal to H/2 in this question?
Yes, sir.
So what could I replace R with?
H/2
So
squared.
And that makes sense as to what we're trying to show, because Jenna, Kamaya, and Sachin, are you all seeing R anywhere in this?
No, sir.
No, sir.
No. So we might have to replace R in terms of H. So R in terms of H is H/2. So let's do that. So anyway you see R, what are you going to write instead, guys?
H/2.
H/2.
Right? So that's going to be V is equal to 1/3 pi. And in brackets, I'm going to put H/2 squared by H. You're with me so far?
Yes, sir.
Yes, sir.
And so let's work this out. So we have 1/3 pi, and then you have H/2 squared. Guys, H/2 squared, what is that? H/2 squared. What's that?
What, radius squared? I'm confused.
Remember, in what we're trying to prove, is there any R?
No.
No,
No,
sir.
sir.
It would be H squared over 4.
Yes, it would be H squared over 4. Jenna, do you understand how we got H squared over 4 now?
Yes, sir, I understand.
If you all are confused though, you have H/2 raised to the power 2. So when you work that out, both of the terms in the numerator and the denominator would end up being squared. So that's going to be H squared over 2 squared. So H squared over 4. Jenna, Kamaya, Sachin, Virginia, are you with me so far?
Yes, sir.
Yes, sir.
Yes, sir.
And we're multiplying that by h. Nice. So you're seeing here that we have a third by, or we have h squared over 4. What's a third by a quarter, essentially? What's that?
1/12.
Now, okay, if you guys are confused, here's a way you can think about it. We can multiply everything that's in the numerator. So we can multiply 1 by pi by h squared by h. What would you end up getting?
Oh, the pi h cubed.
Yeah, you get pi h cubed. Virginia, you understand that, right?
Yes, sir. I understand.
Jenna, Kamaya, Sachin, look at this. If we were to multiply all the elements in the numerator, that would be 1 by pi by h squared by h. 1 by pi is just pi. And h squared by h is h cubed. Let me know if you understand that.
Yes, sir.
And that'll be over what, Jenna?
Over 12?
Exactly. So you all have to develop this analytical skill. Even if you don't fully understand what's happening, you should be able to think about it logically and get the answer. So when I look at this question and I look at the first part, are you seeing R anywhere in the first part?
No, sir.
No, sir.
No, you're just seeing H. So maybe you might have to replace R with something. Y'all catch what I'm saying? Maybe you might have to replace R with something.
Yes, sir.
Right. What is R? What could I replace R with?
H over 2.
Jenna, Kamaya, Sachin, I'll understand what I'm saying, right? R is equal to H over 2. So in this instance, so anywhere I see R, what could I replace it with?
H over 2.
H over 2.
And if I work that out, I'm going to end up with V in terms of H alone. Can you guys see that H is the only unknown in this instance?
Yes,
Well,
sir.
Yes, sir.
I don't want to say unknown, I want to say variable, because you could plug in different values for H. So can you all see that H is the only variable here?
Yes, sir.
Right, so Jenna, if I wanted to differentiate that, I'll only be able to differentiate volume with respect to what there?
Height.
Yes. Cool. So let's read part B now. Calculate in terms of pi the rate at which the depth of the water is increasing when the depth is 4 centimeters. Okay. Guys, if we're talking about depth, wouldn't depth correspond to what? Think about it, like what dimension corresponds to depth?
Height.
Height. Jenna, come on, Sachin, I understand what I'm saying. Like I'm saying that, height corresponds to depth. Does that make sense?
Yes, sir.
All right,
Yes.
Jenna. Okay. So then if that's the case, what do they want us to find here? Tell me.
DH over DT.
Look how easy it is now, right? Stay with me, guys. So how would you find dH dt? Tell me, guys.
DH on top, and then DT on the other side, the bottom, and then
Right.
DV.
Yes. Because guys, if you notice, wasn't dV/dt given to us?
Yes, sir.
Yes, sir.
Yeah. So you could put dV over there, and you could put dV over there. Absolute cinema. And look how easy this becomes, guys. Like, look how easy, like we have dV/dt, right? How am I going to find dH dV? Tell me, Jenna. Tell me. How am I going to find dH dV?
Differentiate the V equals pi H cube over top.
Right? So I'm going to differentiate V with respect to,
Height.
and will that be dH dV?
Yes, sir. No?
Let's write it. That will be d what over d what? You tell me.
Or that'll be dV over DH, but you have to flip it when you
Exactly. So let's find dV/dH. Look, Renisha. Right now we're doing the odd maths. Yeah, check Renisha now way. Yeah, so gonna be dV/dH. So Jenna, how would I differentiate that?
So it'll be 3 pi H squared over 12.
Yes, 3 pi h squared over 12. And you notice that 3 going to 3 one time and 3 going to 12 4 times. So that's actually equal to pi h squared all over 4. I wonder if you
Oh.
catch that.
Yes, sir. But you still
Good.
have to flip it, right? Or is
I
that
still have to flip it.
okay.
So guys, if dVdh is equal to pi h squared over 4, what would dh dv be?
4 over pi h squared.
Right. Virginia, so you raised your hand.
I'm just asking, like, if we differentiate and there's like something in the denominator, do we just ignore it?
I mean,
Like, you know how you just differentiated? I kind of got confused.
okay,
What
no
happened?
problem.
Yeah.
So when you differentiate, you're going to multiply by the power. So what's the power in this instance?
3.
Oh, I see somebody say, what's the logic behind dv and the d stuff? All right. So let me explain. You might see a sentence that looks like this. Water is poured into an inverted right circular cone at a rate of 20 centimeter cube per second, right? So French potato. You're seeing that the volume here changes with respect to time, 20 centimeter cube per second, right? What does that mean? That means that every second that goes by, the volume is increasing by 20 centimeters cube. So if you wanted to take that long sentence and convert it into a single expression, you could say dVdt. So dVdt means that so dVdt is the rate at which the volume is changing with respect to time. So instead of writing this long sentence, you could just say dVdt. And that would tell you that the volume changes at a rate of 20 centimeter cube per second. So dVdt tells you the rate at which volume is changing with respect to time. So we use that notation to indicate the rate at which one thing is changing with respect to the other thing. So that's the purpose of differentiation, rates of change. We're studying how things change with respect to other things. You can think about it like that. Right? So dH over dV by dVdt. So we know that dH dV is equal to 4 all over pi h squared. And we're multiplying that by dVdt. What's dVdt?
20 centimeters per second.
That's 20. Oh, Virginia, I didn't answer your question fully. Let me explain. So, Virginia, you have pi h cube over 12, right?
Yes, sir.
If you differentiate, you're going to multiply by the power. You're going to pre-multiply by the power. So the power is 3. So you're going to multiply everything by
3.
right. So that's going to be 3 multiplied by pi h squared over 12.
Yes, sir. Oh, I see now.
So like I just multiply everything by 3. It just so happens that 3 into 3 is 1, 3 into 12 is 4.
Yes, sir.
You sure you're with me?
Yeah, I'm with you. I just I paused for a second. I was kind of confused.
Here, well, let me give you one to try.
Okay.
So I have a
Differentiate that for me. Oh yeah, Jenna, talk to me.
Alright, if we had to do this again, they wouldn't do it so that we'll get like remainders and stuff.
Yeah,
If
that's
we-
optional. You can get remainders.
Oof, yeah. So it will be the same procedure still if we have remainders, right? Like,
Yeah, it would be the exact same thing. Nothing
okay,
would change. Nothing would change.
okay.
Right? So Virginia, try to differentiate that for me with respect to x.
Would it be 4 pi x squared over 3?
Yeah, there, that would be the case because you're going to put 3 multiplied by 4 pi x squared over 9 and 3 into 3, 1, 3 into 9, 3. You understand?
Yes, I understand. Thank you.
All right, no problem. Cool. So we have 4 over pi h squared by 20. Now, 4 by 20 is what? What's 4 by 20?
80.
Right. And then they want us to figure out the rate at which it is increasing when the depth is 4. So we know that depth is actually height, right?
Yes, sir.
So we'll replace h with 4. Oh, already multiplied 4 by 20, right? So we're gonna end up with this. So that's 80 over pi by 16. So that's 16 pi. But that could be simplified though. How much times 6? I know it's could 16 go into 80? I think that's like 5 times.
Yes, sir.
The answer is what?
5 over pi.
And what would the units for that be?
Centimeter per second.
So like sometimes you just have to follow the logic of the question. You wouldn't fully understand it. You might just have to follow the logic of it.
Yes, sir. I understand now. Thank you so much.
No problem. Kamaya, Sachin, Jenna, let me know if you guys follow understand up to this point.
Yes, sir.
Yes, sir.
Yes,
Alright.
sir.
All right. So, okay. Let me hear. This is a nice question. Part C. Not gonna lie, ChatGPT come up with some nice questions. Not gonna lie. Right, part C. Hence state the rate at which the radius of the water surface is increasing at that instance. So guys, what we actually found was DHDT, right? Yeah?
Yes, sir.
So DHDT is 5 over pi centimeters per second.
Yes, sir.
So what does that mean, guys? What does that mean? What does that mean?
The height increases by 5 centimeters each 5 over pi centimeters each second.
Good. No. They're saying state the rate at which the radius. Let me see if I can figure this out. So that is for height. How can I find for radius?
Divided by 2, because r is h over 2.
Okay, all right. You lie. Ora. Okay, Kamaya, Sachin, Jenna. I'm gonna probably catch what she say. If that's for height, right? And height is 5 over pi. And they want us to find the rate at which the radius of water is increasing. How would I do that? Kamaya, Sachin, Jenna, talk to me.
Divided by 2.
Exactly, because guys, Kamaya, what's the relationship between R and H according to this question?
R is half. Wait, just
Take your time.
half the depth of the water. So
Yeah. R is half the depth of the water. Yeah. So if I wanted to find for dRdt, that would just be what?
this is chain rule.
No, this is much simpler than chain rule.
Oh,
So
okay.
I'll say it again, Kamaya. So, okay, I want you to explain this to me in English. What does that mean?
That means height change in respect to time, which is 5 over pi, and so the units reflect that.
Okay, so every second that goes by, the height is increasing by what?
5 over pi.
Okay, so if the height is increasing by 5 over pi, how would the radius be affected?
It will be half of that.
Exactly, that's all. That's all.
Yeah.
So Kamaya, what's half of 5 over pi?
So why you catching me laughing?
Okay, let me ask that question. How would you find half of 8? You can multiply 8 by what?
Weight by a half.
Yeah, so if I wanted to find half of 5 over pi, I would multiply by.
A half.
What would you get?
You will get 5 over 2 pi.
Yeah. And same unit, centimeter per second, because it's one dimension. So let me run that back again. Let me do a double take. Jenna, I want you to explain to me how and why we divide dHdt by 2. Explain to me, Jenna, why we do that?
So I'm not exactly sure I didn't catch it, but I'll try.
Mhm.
So the question was asking state the rate at which the radius of the water surface is increasing at that instant. So they're basically asking for dr dt. And we got dH over dt to be 5 over pi. So you have to find half of that to find dr dt.
Because R is
Because
equal to
r
H
is equal
over.
to h over 2, yeah.
So if you know the height changing by 5 over pi centimeters and the radius had to change by half the amount, because
Yes,
R is H over 2.
yes, sir.
See, look, you understand. So cool. This was like a harder level question. Yeah. So sometimes you just have to roll with the punches and just go along with it even if you don't fully understand it. Lord knows that's what it's doing in UE level maths that I just use logic. I don't fully understand anything, but I just use logic and let's get it right. So, like, let me try to explain the logic of this. I'll try. So, Jenna, they're saying water is poured into an inverted right circular cone. Do you know what a right circular cone looks like?
Not really, no. Is it just a cone like to the right or something? I don't know.
Okay, so like, that's just a fancy way of saying this. Wait, give me a second. Yeah, Keisha, vi kan gemma på sitt eget show. Like, it really don't have to be complicated, you know, guys. It really does not have to be complicated. So, look at this for yourself, right? So, Jenna, what is that? What is that, Jenna?
Cone?
A cone. And if we take a line from the apex to the bottom, what does that form?
Half of the cone? Right, yeah, half of the cone.
A right angle. So, guys, this is it's a right circular cone. That's what a right circular cone is. It's a circle and it's right angles, you know?
Yes, sir.
And inverted. What does the inverted mean?
Upside down?
Upside.
Exactly. That is all. That is literally it. So they're saying water is poured into this, right? So we pour in water into this. So maybe there's a hole somewhere over here, and you are pouring water into it. You all with me?
Yes, sir.
So when you pour water into this, right? When you pour water into this, the height is going to increase here, right?
Yes, sir.
That looking like a pencil.
I was thinking so in my head.
All right, but y'all with me so far? Like, let me know if y'all understand the logic I'm going with so far.
Yes, sir.
Okay. Jenna, you understand the logic so far? Is an upside down cone with a hole at the top and you're pouring water into it. That's all.
Yes, sir.
And they could have just say that. They could have say a cone upside down with a hole with a hole at the top and you're pouring water into it.
Yes, sir.
Instead, they say water is poured into an inverted right circular cone. Come on, man. And they're saying the shape of the cone is such that at every instant, so every time you pour water, the radius of the water surface, right? So like, let me explain, right? So let's just say I pour water, right? I pour water into this cone, and this is the water, right? Are you with me?
Yes, sir.
Right. What shape would that form?
A circle.
Jenna, what shape would that form?
A circle.
A circle, right? And that circle would have a what?
Radius of
R.
h.
Yes. So because of how this cone is shaped, it's shaped in a very specific way, such that every time you pour water, the water level is going to form, well, of course, at the surface, it will form a circle, right?
Yes, sir.
And at that surface, the radius here will always be half the height. That's what it means. You understand?
Yeah, I think so.
I don't think you understand that. Okay. Because of the shape of the cone, every time you pour water into it, right?
Yeah.
All right, so let's just say you pour water into the cone and you have this so far, like you fill up to this level, right?
Yes, sir.
At the surface, what shape would the surface on the surface? What shape would that be on the surface? What shape would that be?
A circle.
That would be a circle, you with me?
Yes, sir.
And a circle has a what? What's one of the hallmarks about a circle? What's the main thing of a circle?
It always has a radius.
A circle has a radius, right?
Yeah.
Now, Jenna, because of the shape of this cone is very specific. Because of the shape of the cone, at every instance, you know what our radius could be with respect to the height?
H over 2, half of the height, sir.
Yeah. Because of how the cone
Oh,
shape. Because of how
yeah.
the cone shape. Every time you pour water, that radius will always be half of the height.
Oh, that makes sense.
Yeah. So like if you pour your water here, up to this level, the height is this, right?
Yeah.
And the radius is this. And you see that the radius is smaller than the height for sure.
Yes, sir.
Well, I draw the cone wrong, right? The actual cone is in such a way that at this level, like at this point, you would actually see that as half of the height. You actually see that as half of the height.
Okay.
Yeah.
Yes, sir.
So like, let me explain. If the radius here is 4, according to the geometry of the cone, what the height should be?
Half of the radius. No. Wait.
Okay, they say R is equal to H over 2, right?
Yeah.
What I mean, that means that the radius is what of the height?
Half of the height.
Exactly.
So
So what is bigger? Is the radius bigger or the height is bigger?
the height is bigger.
And you can see that for yourself, like no lie, you can see that for yourself. As you go up
Yeah.
closer to the top, like think about it, Jenna. As you fill it and it goes closer up to the apex, the top, what happens to the radius? Does the radius get smaller or bigger?
Get smaller.
Exactly. So like as you fill it up further, you know, the height is gonna increase, but the radius is gonna drop. So it makes
Yeah.
sense. It's like an inverse relationship. So you
Okay.
can see it for yourself here. Like, okay, so if the radius here is 4, then what the height supposed to be?
Oh, 8.
8, yes. So like
Yeah.
over here, if this was let me just say this was okay. You understand this example? Like the first one?
Yes. Yeah.
Let me not confuse it. I don't want to confuse it.
Okay. Okay. Yeah, I
You think you
understand.
understand it?
Yes, sir.
Because of the geometry of this shape, like how it's structured, like how it's made, at every single point in time, the radius will always be half of the height.
Okay. I understand.
Yeah. Virginia,
Yes.
you understand that?
Yes, sir.
Okay, cool. But you don't have to understand that to get the question right, you know? You don't have to understand that to get the question right.
Yeah, I guess so. But I like to understand it.
I understand. Well, you see, like, that's the geometry. That's how the cone is made. It's made such that at every point in time, the radius of the surface will always be half the height.
Yes, sir.
Yeah. So cool. If we ignoring that and we're just looking at it as is, okay, so guys, we're just looking at it as is, right? As is, analytical, purely logical. When you look at it, they're giving you dVdt here, right? That's what they're giving you, dVdt. Let me know if you're seeing that. They're giving you dVdt.
Yes, sir.
Cool. They're giving us dVdt. Let's write that down somewhere. They're giving us dVdt. Cool. And then they're telling us that the radius is how much time the height?
Half of it.
Good. Write that down too. And they give us the formula for volume of a cone. Now, in the first part, they want us to show that V is equal to pi h cubed over 12. Now, guys, are you seeing R anywhere in this?
No, sir.
No. So that most likely means we have to do a substitution and replace R with what? The depth is just the height. Okay, guys?
Yes, sir.
Cool. So 4 over pi h squared by 20, and they always plug in 4 for height. So we do that, and we get 5 over pi centimeter per second. Nice. And then in the other part, they want us to state at which rate is the radius changing. Now, if you know that okay, Jenna, you know that the radius will always be how much times the height? The radius is what of the height?
Half as much as the height.
So exactly, if your height is 5, then your radius could just be half of that. So 5 over 2 pi.
Yes, sir.
Yeah. So we have one more question to do, and we'll call it a day when it comes to rates of change.
Okay, sir.
So yeah, guys, give this a go. I'm surprised. Like we got 40 followers. Like I'm surprised. Like I thought we wouldn't get any followers because it's like
40.
odd math.
Oh,
Because it's
wow.
like odd maths, Like I didn't think anybody would like watch odd maths.
Well, I guess we have more viewers than you expected.
I suppose so. Everybody just excited for the maths. Everybody just waiting for the maths. From what I see, everybody just waiting for the maths. Yeah.
Yeah.
As soon as people see odd maths, they get scared. What if we get so? Is there a cost to this? Well, if you want to get registered for my Form 4 and Form 5 classes, it's $250 a month. You get access to my Form 4 and my Form 5 classes, right? It's an insane deal, as well as these live sessions. You can contact me via my number. Check my profile, or you should see it on your live screen. Contact me, my number right there. But these lives are free. These lives are free. Anybody could come and watch the lives.
So,
Yes, Sachin?
somebody was saying they were messaging you, but they didn't get through.
That's interesting. I don't think I got a message. Oh, I think I got through. Yeah, I saw the message. All right, so guys, this is the exam beast. I think I have what it takes.
Yes, sir.
All right. Sachin, Jenna, talk to my guys. All I have what it takes.
Yeah.
I'll try it. Yeah.
Okay. I give it only 2 more minutes to try our thing. Actually, 3 more minutes. At 9 o'clock, I will correct the question. Okay, sure, we should do a live together, bro. So like I was showing the kids the regular chain rule approach, but you could also use implicit differentiation to solve these type of questions. You could show them down and scare them. Yeah, you could derive the chain rule from the limit definition. That might be overkill though. But if we do a live, you could do that. You can show them that. Yeah, you can show them that. ESS. What's ESS? I don't know what's ESS. Do you guys know what ESS is? ESS.
I don't know. Maybe yes, and they figured you why.
Why would they say please do yes? What?
Oh,
That don't
I
make
don't,
any sense.
I don't know. So I don't know. I was just guessing.
I never check the YouTube chat. I whenever have anybody on YouTube watching. 4 people
Hmm.
watching on YouTube. That's surprising.
Are they commenting?
Yeah, apparently. I was neglecting the YouTube. Sorry about that, guys. I
Oh
was
no.
neglecting all there. So sorry. How much of you guys here are watching this has watched WWE?
On and
Are they
off.
not watch WWE?
My dad does.
I grew up on that. But
Yeah,
like,
I'd only watch it when my dad is, honestly.
okay, so are you ready for me to correct the question or I don't know.
Yes, sir.
Virginia, get through with anything?
I believe I got through with everything. I hope I'm not wrong.
Okay. Jenna, Sachin.
So almost done on the last part.
Okay, well, I'll give it some time.
Same, sir, but yeah.
Okay, so Sachin and Jenna, if you all could get through with this question, are you ready? Are you ready to move on? Yeah. So you will be at a very a high advantage to the people that wasn't there in this class. Yeah.
X mode.
All right, so Sachin and Jenna, they get through.
I think so.
I think so.
All right, so Jenna, Jenna, Sachin, Virginia, which one of you guys want to do the question number?
I don't mind volunteering.
I don't mind either. I don't mind.
Okay. Virginia and Jenna, I'll do rock, paper, scissors now. But Jenna, point the camera there and like do rock, paper, scissors with Virginia. Let me see who go win. And like whoever win, they will do the question.
No, looking chopped.
Don't we all look chopped?
Yeah. Okay. Okay. 3, 2.
All right.
Rock, paper, scissors, shoot.
Shoot. Oh,
Virginia win, boy.
that,
Virginia win.
out of three. I won't like give it a disadvantage. You know.
All right, 3. Okay, okay. So
Yeah.
Virginia won. Jenna, let me see.
Okay.
Let's see.
All right, go.
You got this.
Rock, paper,
Okay.
scissors.
Let's shoot. Oh,
Okay, and even now, even Steven, right?
let's
Okay.
go.
Rock, paper.
Scissors, shoot.
What happened there? What
Maybe we should
happened
do it
there?
together. Let's just do it together.
Do
You
that
know?
again. Okay, all right. So Jenna starts off with the question I
Yeah.
read.
A spherical weather balloon is being inflated with gas at a constant rate of 100 centimeters cubed per second. At time t seconds, the balloon has radius r centimeters. For a sphere, the volume r is equal to 4 over 3 pi r cubed, and the surface area is s equals 4 pi r squared. Continue? Or
Yeah.
okay. Calculate in terms of pi the rate at which the radius is increasing when the radius is 5 centimeters. And
All right.
the
So
sorry.
right. So let me do part A. So here what? Jenna, you're gonna do part A, and Virginia, you'll do part B.
Okay, no
So
problem.
Jenna,
Yes, sir.
for Sachin, I'm not calling on Sachin. I feel I'm bad. Sachin, I feel like in all the classes you should just be quiet and in the background. I don't want to make you feel like a background character.
What?
I
Just
I-
just
I was saying like most classes just be quiet and like I feel like I don't call on you enough. I hope I don't make I hope I'm not making you feel like a background character.
nah, that's just how I just be.
Okay, you like to be behind the scenes, you're like like nonchalant type of guy. You're a nonchalant guy.
It is just be a little too much work now.
I understand. Well, I'll Jenna help
But
out with this.
if you want to do it, it don't really matter.
All right, no problem. Well, this is the last question for you guys for the night, advanced people. But Sachin, you will tell me if you get it correct, right? So, Jenna, let's go. So, Jenna, the
Yes,
first thing I want you to tell me, what does this mean?
So that would give us dV over dt. Because
That's dV
centimeters
over
cube
dt.
is volume and seconds is time.
Clock it. Cool. So we had dV dt. Let me write that down. dV over dt. That's equal to 100 centimeter cube per second. All right, and then they're giving us two formulas. Whoa. All right. So V is equal to 4 over 3 pi r cubed. And then they're giving us S is equal to 4 pi r squared.
Yes, sir.
I'll write that down. So we got how to differentiate one of them, right? If not
Yeah.
two.
Oh.
Then in part A, it is saying the rate at which the radius is increasing. What do they want us to find?
The radius.
What do you mean? Like what do we want to find?
That's dr over dt.
Right, that's dr over dt.
Mhm.
So they want me to find dr dt.
Yes, sir.
How would you do that?
So dr dt is equal to dr on top and dt at the bottom, and then dv. So because they
Because
could
they gave us that. Yeah?
Yeah.
Good
Yes.
job. So which formula would I use to find dr dv? This formula or this formula?
Well, so I use the volume. I'm not sure if that's correct though.
Okay, I want you to stop with this doubting yourself
Okay.
and build up the confidence. Think about it, Jenna. Would it make any sense to use this one?
Not really, no, because it's the surface area.
It's surface area. How you get V? That don't make any sense. So you were
Yes.
right. You were right when you said to use this one. Is it that you'll differentiate this and put it over here? You'll have to do something else.
Yeah, you have to differentiate it, but you also have to flip it.
Good, because it's drdv.
Yes, sir.
Renisha, I see you have your hand raised.
I see. This is advice for Jenna. I was once like that. I was once a person who used to but
You're breaking up a lot.
when you doubt yourself, no, it's the internet. The internet. Sorry. All you hear me now. I was trying to say is when you doubt yourself, you're not giving yourself time.
Renisha, we get it. We get it. We get
To
it.
grow to understand the work. God, so I don't know if you was here, man.
Yeah, we hear you. We hear you. We hear you perfectly.
Perfectly.
Jenna, you getting
Okay,
message?
very well.
Jenna, you getting message? Nice. Nice.
Thank
That's
you.
good.
Uh,
Look, my son. Look, my son Romano reached, boy. Romano, what's he plan?
Well, none really.
I really like that video you edit, bro. Like the video, like okay, like how it was sliding on like it had like different cut screens, like and it continued when you
Yeah.
slide up. That was real bad.
Takes so long.
I can't wait for you to post the video. I will share it all over. I will share it. I'm gonna make a video about it and post it.
I'm posting it tomorrow. I just had to finish the thumbnail. And
Yeah.
well, I'll do that tomorrow and well, I'll post it.
Oh, bet. Well, I will see how I can share it up on thing. Because that's its peak. Right. So let me continue. So Jenna,
Yes, sir.
I hope you learn from Renisha, but let me continue.
Yeah.
So differentiate that for me,
So that'll be 4 pi r squared.
right? Because you multiply by 3, so that'll be 3 by 4 over 3.
4 over 3, yeah. And then minus 1 from the power.
Oh yeah. You see, when I correcting me, I love that. That means like I'll learn the thing. I know they could like sniff BS.
Yes,
Love
sir.
that. So the 3 and the 3 cancel off, so you get 4 pi r squared.
And then you have to substitute, because they gave us the radius is 5 centimeters, so you put that into the thingy. So that'll be 4 pi, that'll be 100 pi.
Yeah, but I
But then
DVDR.
Yeah, you have to flip it to get dr over dv, which would be 1 over 100 pi.
Yep, because that's the same thing as 100 pi over 1. So if you flip it, that would just be 1 over 100 pi. Yeah.
So now we could work out the dr over dt. So that would be 1 over 100 pi multiplied by 100, which would give you pi, I hope.
Not pi.
1
1 over pi.
1 over 5. 1 over 5.
And what's the units for that?
That'll be centimeters cube. Oh,
What
no,
is the
squared.
what is the
No,
unit for radius?
centimeters. Just centimeters.
Right. So that'll be
Yeah.
centimeter per second.
Per second. Yes.
Right. Cool. So that's the first part. Let's do the second part now. So Virginia, now is your time to shine. Sachin, I guess you get that correct, right? Sachin, I guess you get that correct or not?
Wait.
Tell me, Sachin, you get that wrong or you get that correct?
Oh yeah, I get it correct.
All right, cool. So Virginia, read part B for me.
Okay. Hence calculate the rate at which surface area of the balloon is increasing at the same instant. Give your answer as an exact value.
Right. So the way to find the rate at which the surface area is increasing, right? So the really way to find what?
ds dt.
Yes, sir. ds dt. So ds dt is equal, well, we're gonna go on top for sure.
ds.
And we're gonna go in the denominator for sure.
dt.
And they said hence, right? So maybe we might have to use what we just maybe. But let
Yep.
me see.
Well, that's what I did.
So you use dv over here?
No, I'd use dr over dt.
Okay.
And then ds over dr.
Mm-hmm.
So
Okay. You do it a bit different from me then.
oh, seriously? Okay. Well, I was
Yeah.
like, already know dr over dt is 1 over pi, and then I just
Yeah.
differentiated s.
But
Yeah.
that's not a problem. Like, yeah, this is perfectly correct because yeah, the dt is 1 over pi.
Yes, sir.
I was going to do some crazy thing.
Oh, I'd like to see
I didn't see this now. I forget as we find for in the first part. I was looking at this.
Oh, okay.
So I was going to say something like dv over dv. And then that'll be more complicated because you have to do chain rule twice. But
Oh.
yeah. I forget
Okay.
that this is where I forgot that this is where you had to find for in the first part. Yeah.
Well, that's
Yeah.
okay. I mean, you get the same answer.
You get the same answer, but very inefficient. This
Oh, I
this make a lot more sense. Yeah, so that's dRdt.
Yes, sir.
So just to make sure we all understand, we want to find dsdt, right? And I use the word hence, meaning that we might have to use the previous answer. So if we want to find dsdt, then ds has to go on top for sure, and then dt would have to go in the denominator for sure. Now we need to figure out what we're going to use as the other parameter here. In the last part, we found dRdt. So I'm going to put dr here. So dsdr, how are we going to find dsdr?
Differentiate s with respect to r.
And that would be what?
8 pi r.
And they said at the same instance. So what we're going to use for r?
So we'd use 5 for r. So that's just 40 pi.
So that's going to be 40 pi multiplied by
1 over pi.
aha. Look at what happens. What happens?
Pi cancel. And we just be left with 40 centimeters squared.
Craig Gunn, yes, I could do lessons for Laplace transform. It's not a problem. You'll have to contact me though. I'll have to look at my schedule. I wanted to start lessons with Fourier series. Fourier. Multivariate. Yeah. Oh, somebody said, where did I get 5? So let me explain something. The question was, hence calculate the rate at which the surface area of the balloon is increasing at the same instant. At the same instant. In the previous question, it said increasing when the radius is 5 centimeters. So if they say the same instant, then they're talking about this instant when the radius is 5. They said the same instant. You understand? Oh, somebody said how to ask a question. Let me check. Oh, you wanted to know what dv and dr mean? Let me explain. Long story short, if you see dv dt, it just means the change in volume with respect to the change in time. So like if you see 100 centimeter cube per second, what this is telling us that for every second that passes, my volume increases by 100 centimeter cube. So I could write that as dv dt, because dv dt, it tells us that the volume changes with respect to time at a rate of 100 centimeter cube per second. So instead of saying, let me explain. Instead of saying a spherical weather balloon is being inflated with gas at a constant rate of 100 centimeter cube per second, instead of saying all of this, you could just say dVdt is equal to 100 centimeter cube per second. Because dVdt, what it means in English is that it change in volume with respect to time. So in other words, how is volume changing with respect to time? That's what it means. And another example is like dSdt. dSdt would mean what is the change in surface area with respect to time? So as time changes, how does the surface area change? Right? That's what it means. Okay, so cool. So Virginia, you get 40 pi, right? You get 40 pi, and by 1 over pi, it cancel off, and I give you 40. I'm gonna if you
Yes.
understand.
Yes, I understand. But like, I didn't have like 40. I like plugged in the value afterwards. So I had like 8 pi r. I canceled the pi and then I just plugged it in afterwards. But it's more or less
That's
the
not,
same.
is it the exact same thing? That's fine.
Yeah.
Let me ask Jenna a question. Jenna, where's the units? Let me see if Jenna know the units.
Centimeters per second.
What does S stand for?
A second. Wait. So, surface area, sorry.
And area has how much dimensions?
Centimeters squared.
Right. That unit giving you trouble with. Centimeters squared per second.
Per second, yes,
Yeah.
sir.
Right. So Sachin, you're gonna share another way you can work these questions out. Like I'll just show you for one example. No, not gonna show you for all, but one.
Sure.
All right. So which one I should show you it for? I'm gonna think. Trying to think of one I should show you it for. It's a good one I could show you it for. Let's see, like which one make the most sense to show you? Um, okay, so I'll show you it for this, right? So Sachin, in this question, they gave us the formula for volume, right? And they said volume was equal to pi r squared h. Now we know that the thickness was constant, yeah?
Yes, sir.
So then we could replace h for 4. So we end up with a volume of 4 pi r squared. Now, in the question, they want us to find dVdt, right? Well, sorry, they want us to find dRdt. They want us to find the rate at which the radius is increasing. Yeah? dRdt. So let me show you what you would do. You would differentiate implicitly by time on both sides. So like I'll explain. Stay with me. It will look complicated, but it's actually not that bad. Watch. So I'll call this dVdt. And I'll differentiate this with respect to, okay, so it'll be dRdt, right? So here what? I want you to differentiate that for me with respect to r. Differentiate that for me with respect to r. If you differentiate that with respect to r, what would you get?
8 pi r.
And since you're differentiating implicitly, you'll have to put dRdt. So from here, you just have to make dRdt the subject of the formula. But before we continue, let's recall what dVdt was. In the question, they said dVdt was 96. So I can replace dVdt with 96. The radius, what was the radius? In this case, it was 3. So that's 3 dRdt. And the question asks us to find dRdt. So we have to make dRdt the subject of the formula. how would I make dr dt the subject of the formula? Sample.
Move the 8 pi and 3 over to the other side.
Right? And so that will become dr dt is equal to 96 all over 24 pi, and because 8 by 3 is 24, 24 pi, you'll move it across, so that's going to divide. Let me know if you catch that.
Yeah, but it kind of confusing at the same time because in normal math, I would have changed the negative or that mix it up.
No, you wouldn't change the negative. Watch. You have 8 by pi by 3. So you have 96 is equal to 24 pi multiplied by dr dt.
Oh.
So if it's 24 pi multiplied by dr dt, when you move it across, it's going to turn into a divide. So 96 over 24 pi.
Oh, well, now it makes sense, yeah.
And where's 96 over 24 pi?
Oh, 4 over pi.
And that's the answer.
Not easy.
Yeah.
But some situations it'll be kind of hard.
Yeah, but this is something called implicit differentiation. So let me explain. If you had something like t is like r is equal to 5t plus 7, that is explicitly, like what I was saying is like r is equal to something is in an explicit form. And if you want to differentiate that, you could just say dr dt and it would just say 5. That'll be easy to differentiate, right? Because like it's in terms of r is equal to that.
Yes, sir.
But in this instance, is r the subject of the formula?
No.
Nah, see, what you do is you differentiate each term. Like, okay, so in this instance, r is not the subject of the formula. So you're just going to differentiate both sides with respect to time. If I differentiate v with respect to time, that'll be dv dt. And if I differentiate this if I differentiate radius with respect to time, that'll be 8 pi r. So that'll be 8 pi r dr dt. And from there, just make dr dt the subject of the formula. It's kind of complicated to explain implicit differentiation.
So what subject it is use this for?
Pure maths. In pure maths, you'll learn about implicit differentiation unit 2.
Oh, okay.
Let me try to show you another question. So in this question, they say calculate in terms of pi the rate at which the area of the slick is increasing. So they want me to find dA dt, right? Right?
Yeah.
And we know that A is equal to pi r squared, yeah?
Yeah.
Let's differentiate implicitly by time on both sides. Why am I doing that? Because watch, we want to get dA dt. So I'm going to differentiate implicitly by time on both sides. So if I do that, that's going to be dA dt. And that'll be, if I differentiate that, that's going to be 2 pi r. And that's going to be dr over dt. Now, what was dr dt in the question? Like, if you look at the question, what was dr dt?
1 over pi.
Nah, dr dt was 3.
Wait.
So, like, let me go over it one more time, right? So, with implicit differentiation, you're going to differentiate implicitly with respect to time on both sides. So, let me explain. So, you're going to differentiate area with respect to time, right? So, that'll be dA dt. And over here, what variable do you have? Thomas Sachin, what variable do you have?
I said I was watching the wrong one, but it's r.
You have r. So you're going to differentiate that variable r with respect to time as well. So that's going to be 2 pi r. And what did you do? On that side, you differentiated the variable r with respect to time. So you put dr dt. You understand? So both sides, I'm differentiating with respect to time. So I said dA dt on the left-hand side. And on the right-hand side, I have a function in terms of r. So I differentiate r. So that's 2 pi r. And I differentiated that with respect to time. So dr dt. from here, I mean, the question asks us to find dA dt, right? So if I want to find dA dt, all I have to do now is just substitution. So what is the radius they gave us?
8,
8. And what is the dt?
3.
Look how fast you get the answer. What is 8 by 3?
24.
What's 24 by 2?
48.
Bam, you get the answer. 48 pi centimeters squared per second. And that's the answer.
So say if I do this in normal math, add maths, I'll lose marks for not doing it for weekend or no?
They can't take away marks. I mean, it's correct, but like I don't know, because this is like higher level maths. You learn this in unit 2 pure maths in upper 6. So I don't know. Mathematically it's correct. So they technically they can't take away marks, but I don't know if they would give it. I think they'll give it full marks. I'm not sure. I will speak to a marker and let you know.
Okay, sir.
But like guys, look how easy that was. Like Virginia, you see how fast we get the answer? Like
Yeah, that's so crazy. I wish we could have done this.
Like, let me show you with another question. Like, this is so easy. So, like, I'll explain the concept, right? So, we want to find dA dt. So, what we'll do is we'll differentiate with respect to time on both sides. So, I'll differentiate area with respect to time implicitly. So, that would be dA dt. On the right-hand side, I have a function in terms of our variable, Virginia. What variable do I have on the left hand? I mean, on the right-hand side.
In terms of R.
Right. So, I'll differentiate that function R with respect to time. So
Yes.
I'll say 2 pi r dr dt. Now, the question wanted us to find dA dt, right? So to find dA dt, I just had to substitute now. R was given us 8 and dr dt was given us 3. Bam, I get the answer.
That's so easy. Oh my god.
Let's do another question. Like, this is real simple. Like, I could do it from 8. Like, look how easy that would be. Add page after. I will enjoy unit 2 pure maths. It's fun.
Yeah,
So
really.
So we have V is equal to 4 over 3 pi r cube. V is equal to 4 over 3 pi r cube. And in the first part, they want me to find dr dt, right? Honestly, in that they want me to find dr dt.
Yes, sir.
All right, so let me follow the steps. So they want us to find dr dt. So I'm going to differentiate implicitly with respect to time on both sides. So on the left-hand side, I'm going to differentiate with respect to time. So that would turn into what?
dVdt.
That would turn to dV dt. Over here, I have a function in terms of r. So I'll differentiate that with respect to r. And I'll get what?
4 pi r squared.
No, I differentiated a function r with respect to time. So that'll be dr dt. Now, in the question itself, weren't you told what dV dt was?
Yes, sir. 100 centimeters cubed per second.
Right. 100 centimeter cube per second. So we could substitute dV dt for 100. And we were also told what r was. I think r was 5. R was 5, yeah.
Yeah.
So from here, you just had to make dr dt the subject of the formula. So 5 squared is 25, and 25 by 4 is?
100.
Right, so that's going to be 100 pi by dr dt. And if you make dr dt the subject of the formula, what are you going to do?
Carry across 100 pi.
Right now it's multiply, right? So when you carry it across, I got into 1.
Oh, you divide.
Bam,
So
you
that's
get the answer already.
pi. Wow.
Yeah. Yeah, that's it.
That's so crazy.
Talk to me. You understand that? You understand that method? Implicit differentiation?
Yes, sir.
Sachin, you understand that?
Yes, sir.
Yeah, I wouldn't say it hard. Implicit differentiation, easy stuff. I had the video on YouTube, so I can always go back and look at how I did it, but
Yeah.
stick to the method that they're expecting.
I'll just keep it as like general knowledge.
Well, you go pull it back when you go into Unit 2 Pure Maths.
Oh, that's true.
So we are officially done with rates of change. We done.
Yay.
How are you guys feeling about rates of change? Jenna, how are you feeling about rates of change?
So I feel a lot more confident than where I was before.
That's good. And hey, Jenna, let's do some exercises. Jenna,
Okay.
what unit is radius?
Centimeters.
What unit is area?
Centimeters squared.
What unit is volume?
Centimeters cube.
What unit is height?
Centimeters.
Here, what? Anytime we measuring our length, centimeters.
Centimeters.
Yeah.
Okay.
So height is our length, right? Until we measure height with a ruler.
Yes, sir.
Yeah. Cool. So I'll send us documents, but we're done. Now it's time for regular maths. I might do a 1.5 hour regular maths and I'll call it a night.
Okay, so don't forget about the differentiation homework questions from like the week before last week.
I'll go do that on a different life,
Yeah.
So,
right? But yes, I shouldn't talk to me.
that is it for differentiation or no?
Yeah, that's it for differentiation.
Wait, so say you do limit already?
Yeah, we did limits already. I don't think it was there though.
No.
The definition of a derivative was a limit, where you use limit as h approaches 0 for f of x plus h minus f of x all over h. That what you're talking about. And that's what
Yeah.
you're talking about?
Yeah,
Yeah,
so
that's right. It's in the class recording somewhere. Just have to check any Form 5 recordings, you'll see it. Watch. If I scroll up to the top. This is what you're talking about.
so they're in a Google Classes or something?
Say that again?
Is it in a Google Classroom?
Now, okay, go on the Form 5 math description,
Mm.
the group description, and you'll see recordings for Form 4 and Form 5. And you just click Form 5 recordings on YouTube and you'll access the recordings.
Oh, okay.
Let me know if you get through. So you're gonna go on group description like this.
Yeah.
And you'll see Form 5. You click the link. And you'll see all the recordings. Right? So you're gonna look at concept of differentiation. Concept of differentiation, and you'll see first principles. First principles is this. Yeah.
Okay, so
Right? Cool. So let me just give me a second. I'm going to